Course 3, Lesson 79, we will be looking at transforming formulas, and in this video we will also be looking at Lesson 80. So first, when we are transforming formulas, oftentimes we are given formulas, but sometimes we want to know different information. So we need to change the different formulas in order to make problems easier oftentimes. For instance, if we have our equation distance equals rate times time, d equals rt, what if we needed to solve for rate or time? Meaning, how would we transform this formula in order to get r by itself or t by itself? So first, let's transform this formula for r. And if I want r to be by itself, that means that this t has been multiplied to it. So I need to divide by t in order to find my rate. So rate I can actually find by taking distance and dividing by time. Similarly, I can take my d equals rt and solve for time by dividing by rate, so that I can always find time by doing distance divided by rate. So let's say we have 240 miles and 60 miles per hour. That means that I can use this formula right here to solve for time, so that I can do 240 divided by 60 will give me my time. So it looks like my time is 4 hours. Okay? Looks like it will take those 4 hours to go those 240 miles. Alright, let's solve another one. So in this case, we have this length w that we can say is x plus b. Well, what if we wanted to know what x was? We had information for w and b, so what would x be? Well, in this case, x plus b, we need to get rid of that plus b, so we do the opposite and subtract b. So we have w minus b is equal to x. So really, our rules for solving equations stay the same. We use the opposite operations in order to solve these equations. So just like we solve for x, let's solve for b. And in this case, b has had x added to it, so we need to subtract x. So I have w minus x is equal to b. And just like the previous equation, we wouldn't be able to combine w and b because those are not like terms. All right, another one. Circumference equals pi times diameter can be used to find the circumference of a basketball. Solve the formula for diameter. Then solve it for pi. So let's solve for each of these. And in the first case, we have circumference equals pi times diameter. So to solve for diameter, I'm going to need to divide by pi on both sides. And we see that diameter can be found by doing the circumference divided by pi. Now, if I wanted to figure out how to find pi, I could take my original circumference equals pi times diameter, and in this case, divide by diameter. So pi can always be found by doing circumference divided by diameter. So we can always transform these formulas for a different variable. The formula for the area of a rectangle is area equals length times width. Solve for length. And then we're going to find the length of a rectangle if the area is 42 and the width is 3. So we say, all right, if I have area equals length times width and I want to solve for length, means I need to get rid of that times w by dividing by w. So length is actually area divided by w. So in order to find the length in this problem, I'm going to do length is equal to 42 is my area, divided by 3 my width. So that I say, okay, 42 divided by 3 is 14. So the length would be 14. All right. A couple more examples here, and then we'll move on to lesson 80. So area equals pi r squared. We need to solve for r. And then we're going to find the radius of the circle with the area of 154 centimeters squared, and we're going to use 22 over 7 for pi. So if I have area equals pi r squared, well, to solve for r, I first need to divide by pi. So I would say r squared is equal to area divided by pi. And then I'm going to say r squared. Well, to get rid of that squared, the opposite is square rooting. So I square root both sides. And I say the square root of a divided by pi is equal to the radius. So if I wanted to find the radius, I could plug in the information that I have. So I'll do the square root of, see, the area is 154 divided by pi, which we're going to use 22 over 7. Now in here, I could do 154 and then multiply by the reciprocal. Since we're dividing by a fraction, I can also multiply by the reciprocal, so 7 over 22. Well, if I do that, 154 times 7 divided by 22, yes, there are things that we can simplify. But regardless, I end up with radius equaling the square root of 49 when all is said and done. 154 times 7 gives me 1078 divided by 22 gives me 49. And then I can say, well, my radius must then be 7 units. 7 centimeters in this case. Okay? So we can solve for the radius by plugging them into my transformed equation. All right, and solve the equation P equals A plus B plus C for A. Well, that means that I need to get rid of this plus B and plus C. So we'll start by subtracting B from each side. So we'll say P minus B is equal to A plus C. We're a little bit closer, but we still need to get rid of this plus C by subtracting C. So I now have P minus B minus C is equal to A. Okay? And lastly, solve the Pythagorean theorem for C. Well, the Pythagorean theorem is A squared plus B squared equals C squared. So to solve for C, I would need to square root to get rid of that squared, and I would square root the entire other side. So I would say C is equal to, well, we can't simplify the square root of A squared plus B squared. Because of that plus, we're not able to simplify those squareds, and we just say C is equal to the square root of A plus B squared. A squared plus B squared. All right, let's transition into lesson 80. All right, so let's look at lesson 80. And for lesson 80, we are adding and subtracting mixed measures, and we're looking at some polynomials. So lesson 80, the first thing, sometimes we are given measurements in different units, and we need to be able to add and subtract them. Yes, we could transfer them all into the same units, but we can actually add and subtract them as they are. So for example, if we have 27 minutes and 15 seconds, 48 minutes and 28 seconds, and 42 minutes and 53 seconds, we need to add all of these up. Now we always start with the smallest bit of the measure, so the seconds. We're going to start there and add up just like normal. So 5 plus 8 is 13, plus 3 is 16, and we carry. Okay, and then we say 1 and 1 plus 2 is 4, plus 5 is 9. So we actually have 96 seconds here. Now, yes, we will convert that into minutes in a second, but we're going to add up my minutes now. So 7 and 8 is 15, plus 2 is 17. And then 1 and 2 is 3, plus 4 is 7, plus 4 is 11. So we have 111 minutes in 96 seconds. But you're probably thinking, that's not what we would normally say. Because at 96 seconds, that's over a minute. So we need to convert that into how many minutes and seconds it is. Well, 96 seconds is really 1 minute and 36 seconds. Oh, sorry about that. 36 seconds. So we need to add that to what we currently have, and we would say, all right, so I'm going to add a minute here, so we have 118 minutes, and we now only have 36 seconds. So we need to convert it to full minutes and seconds that are not over a minute. So we always cut it off at that 60-second mark. Let's try it again. Sally weighed 7 pounds, 12 ounces when born. She now weighs 12 pounds, 5 ounces. How much weight has she gained? So in this case, I want to note the difference between these two from when she started and where she is now. So I subtract. So in this case, I have 12 pounds, 5 ounces minus 7 pounds, 12 ounces. But when we look at that 5 minus 12, we say, well, I can't do that. But I can borrow something from my pounds. I can say, well, that 12 pounds and 5 ounces, I could also say that's 11 pounds And let's see, how many ounces are in a pound? Well, we would say there are 16 ounces in a pound. So instead of 5 ounces, I'm going to add 16 and get to 21. So that I can subtract them and say we have 9 ounces, and subtract 7 from 11 and get 4 pounds. So she has gained 4 pounds and 9 ounces. Okay, so we can borrow just like we would with our normal subtraction, but in this case we need to think about how much is that 1 that we are borrowing. In this case, 1 pound is the same as 16 ounces, so we would use that for our subtraction. All right, next one. Last year Marie completed a mile in 12 minutes, 15 seconds. This year she finished in 9 minutes, 48 seconds. How much did she improve by? Once again, we need to find the difference between these. So we're going to subtract. Once again, we have too few seconds here to subtract 48 from. So we need to borrow a minute. So we have 11 minutes, and we're going to add then 60 seconds to my 15 seconds and have 75 seconds. So now we can actually subtract them. And we subtract and we borrow from this 7 and get a 6, 15, so we have 7. And 6 minus 4 is 2. So the difference between 75 and 48 seconds is 27 seconds. And we subtract the minutes and get 2 minutes. So she has gotten better by 2 minutes and 27 seconds. All right. Now, how this relates to our polynomials is, remember, polynomials are algebraic expressions, and we have different terms to talk about them. So monomial is a term that involves a constant or a product of constants, and this is just one term. It can involve different coefficients and variables, but it's just one term altogether. So, for example, we have 2xy, just a, just 9. Whereas a binomial consists of 2 terms. And we can see examples of 9a plus 3, a squared minus b squared, x plus y. We call these binomials because that addition or subtraction sign is what is separating our 2 different monomials. And trinomials, very similar, consists of 3 terms. So 11x squared minus 3y plus 2. That minus and plus separate these 3 terms. And x plus y plus z, those addition signs separate our 3 terms. So we can talk about the degree of a polynomial. And the degree of a polynomial is the highest degree of any term. What that means is that when we look at our different terms, x, x squared, x cubed, we would say the degree of these is based on their exponents. So x has a degree of 1 because it has an exponent of 1. X squared has a degree of 2. X cubed has a degree of 3. And so if we look at our binomial, 4y squared plus 3y, we would say, well, 4y squared has a degree of 2. Because that y squared is what we're looking at, and its exponent is 2. 3y has a degree of 1. And if we're looking at the overall degree of this polynomial, we talk about it using the highest degree, in this case, 2. All right, so in each of these cases, let's look at their degrees. And first, let's look at these monomials. For a c, if we have a monomial, and we have more than one variable that we're looking at, we just add up all of the exponents, not on the constant, but just the exponents on the variable. So this one has a degree of 2. 6xyz has, well, all of these have exponents of 1, so we add all of those up. This monomial has a degree of 3. A squared minus 4, well, the a squared has a degree of 2. And the minus 4, since it doesn't have any variables with any exponents, has a degree of 0. So overall, this polynomial has a degree of 2. M plus 3, well, the m has a degree of 1, and the 3 has a degree of 0. So overall, this has a degree of just 1, because that is the highest degree of any of the polynomials, any of the monomials. And 5abc plus 2, the a has a degree of 1, or the a has an exponent of 1, b exponent of 1, c exponent of 1. So overall, this monomial, 5abc, has a degree of 3. And 2, since it doesn't have any variables, it once again has a degree of 0. So overall, this has a degree of 3. Now I want to show you one other example to really show you exactly what's happening. If I have 3y squared x plus 4a squared b to the third minus 5a. Now I want to find the degree of each of these monomials and then figure out which one is the highest. So with 3y squared x, that has a degree of 3 because those exponents add up to 3. And 4a squared b cubed, all of that adds up to a degree of 5. And negative 5a has just a degree of 1. So overall, we would say that this polynomial has a degree of 5 because that is the highest degree of any of the monomials. All right, so let's find the degree of each of these polynomials. Okay, so we need to find the degree of each monomial. So 4x cubed has a degree of 3, 2x squared has a degree of 2, x has a degree of 1, and negative 3 has a degree of 0. So overall, the degree of this polynomial is 3. Same with the next one, a degree of 2 for x squared, degree of 1 for 2x, and degree of 0 for 3. So overall, it has a degree of 2. And x plus y plus 3, x has a degree of 1, y has a degree of 1, and 3 has a degree of 0. So overall, this has a degree of 1. Sometimes the polynomials are not arranged in standard form. So we need to make sure that we have them in descending order of exponents, meaning highest to lowest. So let's find the degree of each, then put them in order. So in the first one, x has a degree of 1, 2x cubed has a degree of 3, 2 has a degree of 0, and x squared has a degree of 2. So we put them in order saying 2x cubed should go first, and then plus x squared plus x plus 2. So descending order. Similarly, we're going to start this next one out with x cubed, that's the highest degree, minus 4x squared, that's next, minus 6x, and plus 5. All right, degree from highest to lowest is the standard form of any polynomial. All right, we can also, just like we did with our measures, we can add and subtract polynomials. We need to, though, make sure that we are adding and subtracting with those like terms. So, for example, with this first one, x plus 6 plus 2x minus 3. We can rewrite this in order with basically grouping the like terms. So I could write it x and then a plus 2x. Okay, those are like terms. And then plus 6, and we have a negative 3. Now the reason I can do this and just take them out of their parentheses is because of this addition sign. I'm able to do that because truly I am adding a 2x and adding a negative 3. If it were a subtraction sign, we would have to distribute that subtraction sign before moving them into their groups. So that I can say x plus 2x, well that just means I have 3x. And 6 minus 3 is just a plus 3. So overall we have 3x plus 3. Same with this next one, I'm going to move them into their groups. So I have an x plus x. All right, so I dealt with that one and that one. I have a y and a negative y. And I have a minus 2 and a plus 4. So that I can combine each of these to say this is 2x. Well, y plus a negative y is 0. It goes away. And negative 2 plus 4 gives me a plus 2. Oops, sorry, plus 2. So we end up with 2x plus 2. All right, so let's just practice going back to our original adding these measures. So I need to add 3 hours, 32 minutes, and 45 seconds to 1 hour, 43 minutes, and 27 seconds. Oops, sorry about that. Let me close that. And let's see, 27 seconds. All right, so we need to add these up. So let's start with the smallest bit. So the second 45, 5, 12, 4, 1, in our minutes, we have 5 and 7, 75 minutes, and we have 4 hours. Once again, we're not going to keep it like this. We need to convert the 72 seconds to 75 minutes. go over that 16 outside. Alright, now for subtracting, I'm going to do the bottom one here. 6 feet 2 inches and 4 feet 7 inches. So we have 6 feet 2 inches minus 4 feet 7 inches. Well, I already considered that I'm going to have to borrow these. I can't do 2 minus 7. So I'm going to borrow a foot, and remember that there's 12 inches in a foot. So instead of 2 inches, I can have 14 inches. So 14 minus 7 I can do, and it's 7 inches. 5 minus 4 is 1. So I always need to borrow a certain amount, especially if it comes up different. Alright, and I'll let you do this one on your own. And I hope this is helpful for your homework for 7.